In this video, I'm going to show you how to go over extra practice exercise 3 from chapter 16. So the question says, predict whether the dipotassium salt of citric acid will form an acidic or basic solution in water. Look up the Ka values on page 24. So I added the chart from page 24 so we see the 3 Ka values there. And what I like to do with a polyprotic acid problem is always write down my 3 Ka reactions, at least in the beginning while we're learning this right now. So Ka1, you start with a fully protonated acid. And again, looking at this, I know that each of my potassiums is a K plus ion. That means that I'm looking at the Ch16H5O7 2 minus ion. So Ka1, you start with the fully protonated, so that must have 3 protons to neutralize the 2 minus. A Ka reaction, you always react it with water. And we have our acid and base. Acids are proton donors. So we form H2C6H5O7 and hydronium. And we're told that Ka1, 7.4 times 10 to the negative 4th. Ka2, you start with the, should be minus 1 ion. The minus 1 ion you just formed, so H2C6H5O7 minus plus H2O liquid. Equilibrium because it's weak acid. HC6H5O7 2 minus plus H3O plus. And Ka2 is given as 1.7 times 10 to the negative 5. Ka3, we're forming we start with the 2 minus that we just formed, HC6H5O7 2 minus, equilibrium, C6H5O7 3 minus, and hydronium, Ka3 equals 4.0 times 10 to the negative 7th. So now the question is asking, will the HC6H5O7 2 minus ion be acidic or basic? So if it's acidic, we have a Ka value of 4 times 10 to the negative 7th. And I know it'll be acidic if my Ka for that amphoteric species is larger than the Kb. So the reason this is a valid question is because HC6H5O7 2 minus is amphoteric. It can act as an acid or a base. So as an acid, we have a Ka of 4 times 10 to the negative 7th. Well, let's figure out what is the Kb, and we can compare. So as a base, and water is an acid or a proton donor. And a reminder, this was an acid, so water is a base. Bases accept a proton, so I'm forming H2C6H5O7 minus and hydroxide. And this is a Kb reaction because I'm looking at a base reaction forming hydroxide. So we're going to have Kw over Ka, and the key is to figure out which Ka do I divide it by. Is it going to be Ka1, Ka2, or Ka3? So the key is to look and figure out which Ka equation gives me the relationship between the H2 C6H5O7 minus and the HC6H5O7 2 minus. So I can see the Ka that does that is my Ka2. I have the H2 minus 1 ion and the H2 minus ion. So that means I'm going to be dividing by Ka2. So Kb is Kw, constant, divided by Ka2. So in this case, Kb equals, so on the calculator, got to type in 1 times 10 to the negative 14th divided by 1.7 times 10 to the negative 5th. Enter. And I get 5.9 times 10 to the negative 10th. So now what I need to do, I know that if Ch16 acts as an acid, I have a Ka of 4 times 10 to the negative 7th. If it acts as a base, I have a Kb. So again, this is for Hc6H5072- of 5.9 times 10 to the negative 10th. So to figure out, will Hc6H5072- be acidic or basic in water, we have to compare. So my Ka, which is 4.0 times 10 to the negative 7th, versus Kb of 5.9 times 10 to the negative 10th. And I can see that Ka is larger, so K2 Hc6H5072- will be acidic in water. So that's how we figure out if the solution will be acidic or basic. And if the question asks to calculate the pH, I would just use my Ka reaction and that numerical value for Ka, set up a standard icebox with the molarity that would have to be given, and you could then solve for X. X stands for hydronium, and get the pH that way.